And now I would like to discuss the difference between population regression function and sample regression function. And to do that, I've decided to use a hypothetical example. So let's assume we've got 60 families which constitute the entire population of a certain community. So 60 families is not a sample, this is the entire population. We've got some data on these 60 families like Y, which is weekly consumption expenditure, and X, weekly income. In addition, 60 families have been divided into 10 income groups from 80 to 260. And this table over here is a quick summary of what I've just said. So X, once again, this is the value of income from 80 to 260. Y, this is weekly consumption expenditure. And here we've got it in this part of the table. So for each group, the total has been calculated. So the sum of individual consumption expenditures. So for the first group, this is 325. And after that, the average for each group has been calculated. So in case of the first group, 325 has been divided by 5 because there are 5 consumption expenditures. In case of the second group, 462 has been divided by 6 because there are 6 consumption expenditures, and so on and so forth. So in such a way, we've got these numbers, which are the conditional means of Y. So what conditional mean is, it's the following. So this is the average of Y given the value of X. So in case of the first group, that will be the average consumption expenditure given the value of 80 for income. In case of the second group, for example, 77, this is the conditional mean of consumption expenditures given the income of 100, and so on and so forth. So after this table has been constructed, the following graph has been drawn. So the large dots on this line, those are the conditional means, 65, 72, 89. So we just put them on a graph against the income group they belong to. So that would be 65 for 80, 77 for 100, and so on and so forth. After that, we connect the dots and we get this straight line. And the straight line is known to be a linear population regression function, which is the regression of conditional means of Y on X. So in our case, this is the regression of 65, 77, 89, and so on and so forth on X, which is 80, 100, 120, and so on and so forth. So beta 1, this is the intercept of this function, and beta 2, this is the slope of this function or the slope of this line. Unfortunately, no regression model is perfect, and there is always some information missing, and there are a number of reasons for that. For example, the theory might be not that clear, right? So we think that we know the theory, we think that we are correct, but in reality it might happen that the theory is quite vague, and because of that, the model is not really complete. There is also another common problem, and I think that you will also face this problem in the future, is unavailability of data. So you come up with an amazing model and then you go to the database and your dreams crash completely because there is no data available. Another reason for non-perfect regression is exclusion of important variables, and I think it mostly has to do with unavailability of data. Another interesting reason is the randomness of human behavior. We economists want to believe that human beings are rational, but unfortunately this is not true, and human behavior is quite random, and because of that there might be some information missing in the model that we try to estimate. Another reason for missing information could be wrong functional form. We still haven't discussed any functional forms, but I promise you we will do this in the next few classes. So for now, just believe me that wrong functional form might be the problem, might be the reason for missing information. But luckily, we can account for these missing factors by introducing something called the error term into the regression. Usually it is denoted by U, and this is how the final equation looks like. So y is a function of x, and there is an additional variable, which is the error term. Let's discuss the error term a bit more. It has some synonyms. For example, it can also be called the disturbance term or a residual. And I think this is a very wonderful definition of what an error term is. This is first of all a proxy for all the omitted or neglected variables that may affect y, but are not or cannot be included in the regression model. And mathematically, the error term is calculated in the following way. So we take the actual values of the dependent variable, so of y variable, and we subtract its estimated values, right? We get those. So this, what we have in the brackets, beta1 plus beta2 xi, this is the estimated values of the dependent variable. And the difference between the actual and the estimated one is the residual. You can also see it on the graph. I've taken it from the previous class. So a dot, this is yi. This is the actual value of the dependent variable, in our case, consumption expenditure. And what we have here on the line, those are the estimated values of y, the one that we get from this beautiful bracket.